So what's the difference between bivariate regression and multivariate regression? So why would we move from this two variables to the wall of numbers like this, right? Or why would I bother focusing on the bivariate when like it's this multivariate stuff that people end up doing much more often. And there's three big key differences that really help explain why multivariate regression is such a powerful tool and why it's used so often in political science and elsewhere. The most important thing is that multivariate regression examines the direct effect of several x's on one y in a single statistical test. And I'm using x's and y's deliberately here. It would be an error to say that it tests the direct effect of several independent variables on one dependent variable in one test, because we're always building in things like potential sources of spuriousness, variables that we think might actually be conditional. We have to do extra stuff that's well beyond the scope of this class to actually do the conditional testing in the context of a regression. But in order for us to, the first step for us to do it is to include them in the single model. So it's like taking your original relationship that you're interested in, competing explanations, sources of spuriousness, and causal mechanisms all into account, all at the same time, in a single test. So this is the really powerful thing that multivariate regression allows us to do that bivariate regression and honestly crosstabs don't. We can test for so many more explanations, controls, things that we care about in one go. And this is the thing, if you're finding yourself with your research report, if you think about it and you're it's neat that you get to test for this hypothesis with an independent variable and a dependent variable, and then you've got these three control variables. But if you stop and think about it, it shouldn't take too much to be this is an oversimplification of how the world works. We do need to be able to take some stuff into account simultaneously, just to be able to disentangle their effects, right? Multivariate regression allows us to do that. That's the first big key difference. The second key difference is that multivariate regression is much, much more common in empirical political science. And I would say that it's a dominant technique, if not one of the most common techniques that gets used for people who do this kind of research. And that's true in political science, but I also think it's true in fields like sociology. A lot of economics uses this as its foundation as well. The study of econometrics, it's much more mathematical than the way that we would use it over in political science, but we use a lot of the same techniques, right? And so once you know what's going on in a regression, you can see it across diverse subject matter, or at least diverse fields, right? And still be able to know what's going on, at least with the statistics. The third difference, and if you're sitting there being why did you bother teaching us the bivariate stuff if you never use it? And I did say that, that one piece is literally the only time I've published a series of bivariate regressions in my life. So if you're why did you bother to take the time to talk about that? Bivariate regressions are easy to draw. Multivariate regressions are not. They're really not. As soon as we move past two x's and one y, which we almost always do, you know this from the wall of numbers, right? We've moved into space that we can't see with our brains. We move past three-dimensional space, and you can think about it in the abstract, but drawing it to be able to understand what's going on, nah, we just don't do that because it's hard, right? Okay, so those are the three key differences between bivariate regression and multivariate regression. We can examine a whole bunch of x's, our independent variables, competing independent variables, intervening variables, sources of spuriousness. We can do it all in one go for one dependent variable. Many x's, one y. That's the first thing. The second thing, super common, it's dominant across multiple fields. So if you know it in this context, you should know it in other contexts too. And then the third thing is that it's so much easier to draw the bivariate relationship than the multivariate relationship. So you'll see this in a moment here. It's simply Understanding the algebra behind multivariate regression, it gets a little bit more complicated, but at least in terms of like what the equation looks like or what we're actually asking the computer to do. If the bivariate regression is just like y equals a plus bx plus e, all multivariate linear regression is then y equals a plus b1x1, b2x2, b3x3. So you're doing these multiple slopes, these multiple lines for each independent variable. And so you just like do all of them, and then you still have your kind of like collective error term at the end. So you've got your dependent variable is still y, your independent variable or potential source of spuriousness or intervening variable, all of those things, those are a potential x. And then you still have what a means in that context, that intercept is when all of the independent variables are 0, all of them. So you need to know what it means for all of those independent variables to be 0, and that will tell you what that intercept means. Sometimes it doesn't make a whole lot of sense, to be honest. Sometimes it really doesn't make a whole lot of sense. So we sometimes don't interpret it in that context just because it's like kind of divorced from the real world. What we care about is like the effect of each independent variable to move the dependent variable, and while taking a whole bunch of other stuff into account. And like I say, that E is that error term for the entire kit and caboodle altogether. Okay.
Hi.
Okay.
Things that we look at in a regression, we usually look at 3 different statistics in a regression. The first is that R squared. So in a multivariate regression, you still get an R squared. And in this context, it's the proportion of the variation in your dependent variable, that proportion of variation in y, that's explained by the whole combination of independent variables in your equation. And so if you're thinking about like the number of times I've said like political behavior is complicated, or human behavior is complicated, or the way that we see politics is complicated and it's like got more than one thing that's causing it all at the same time. I have partial intervening variables. So this is why you want to do the multivariate model, so that you can look at all of these things at the same time. And then that R squared tells you how much of your dependent variable, the variation in it, you're explaining with everything that you've taken into account. That's the R squared. The second thing you need to know is something called the F test. And this is the statistical significance of the model as a whole. So this is the statistical confidence that we should have in the model. And it's kind of like asking, this model that I've got here, these results, how likely is it that they're due to chance? What are my odds of making a type 1 error with this model? Usually you really do need your model to be like the same thresholds apply, but like if your model is not significant, something has gone, there are things that have gone wrong, usually with your sample, various sorts of things, or you're like doing something, you're theorizing things like in a way that's not useful and the model's like bonking out as a result. To be honest, is often like poor theoretical choices that get you to this point. But that F test gives you the statistical confidence in the model. And then you have something called a T test, which is for each coefficient. That's where you get the stars in your wall of numbers. The stars are the t-tests, and each t-test is just saying the statistical confidence that you should have in the effect of that coefficient, the effect of that one independent variable, the effect of that one x, being significantly different from 0. So anytime you see a wall of numbers, if you've got that star that's telling you, is that like number, like is there an effect there from that x on y? And how confident am I that it's distinct from 0? Can I be confident that I'm not making a type 1 error if I want to say that that factor actually does something to the dependent variable? That's the t-test. So you've got R squared, you've got the F test, and you've got the t-test. And the ones that you're going to encounter most often in your other coursework are those t-tests, because those are the stars in your wall of numbers. That's what the t-test is. Okay. So one of the things I want to encourage you to think about, particularly when you're reading wall of numbers, because this comes from like a multivariate regression. Substantively, the importance that any one of these particular factors has for the dependent variable, for the way that we want to talk about the political problem that we're studying, like the actual substance of what we cares about, that requires an assessment of the relative effect of each variable on the dependent variable. Or another way of saying this is that in a regression, the numbers that we have in this wall of text are coefficients. There are coefficients that are associated with each variable. And we want to look at the, like, substantively, do the statistics tell us that, like, we can make an argument that there's a substantial effect, that there's something really important that each one of these variables is doing? Is, like, how important is each given coefficient to the dependent variable? Okay, so I'm going to give you two examples of this. One is only going to be 3 variables total, just to try to keep it simple, because we can still draw that, and also trying to get at the logic. It's similar to what you would do for your research reports. And then one is quite literally this wall of numbers.
We're building a wall
that I keep pulling up as my example. Okay, so that more simple one first. This is a made up example because real world data would never look this neat. And so we've made it up for the purposes of illustration. Here we're looking at attitudes towards reproductive health, in particular, how people feel about abortion. And so the hypothesis is looking at how age helps predict attitudes towards abortion. The hypothesis in this case is the older someone is, the more likely they are to oppose abortion. So, or you could say older people are more likely to oppose abortion rights than are younger folks. There's a easy causal logic that comes from this. People who would have been my mother's generation would have not have been able to access a lot of reproductive health care, right? My mom was born in 1951. And so a lot of agitation around equity and gender rights was in a lot of ways ensuring that women actually could control their own, like when they would actually choose to have a baby or not. And when the state could come in and tell you that that you actually are forced to carry on with a pregnancy that you don't want. And so you can see how, like, as the legal status of that has changed in various places, and that legal status is going to come along with socialization about what's an appropriate level of state intervention in that level of reproductive health care. One of the things I want you to think about is, if you remember the Irish constitutional referendum on this, where you have like hundreds, if not thousands, of young Irish women who were living abroad flocking back home to vote in that particular referendum to make it, like, to give women the constitutional right to control their like when they get pregnant, basically. So the Irish example is the most recent one. But you can think about it in a more diverse context too, or like broader context, where, like, as the legal, like, frameworks around this change, so too might people's attitudes. And so as we move through time, younger folks who are used to having these rights in place are going to be more supportive of those rights than people who grew up in a context where, say, some of this stuff was still criminalized or very difficult to get at. Anyway, so that's the logic behind this, behind the idea that age might predict how people think and feel about reproductive health care, in this case specifically about abortion. Our sample in this example is 100 imaginary Canadians. And so the way that we're going to measure these attitudes is we're going to use one of those 0 to 10 scales. So this would be our dependent variable is on a 0 to 10 scale. We could ask people, on a scale of 0 to 10, please tell me whether or not you think abortion can always be justified, never be justified, or something in between. And so what participants are responding to is this idea that 0 means that, like, abortion is always justified and 10 is never justified. So bigger numbers equal greater opposition to abortion rights. The level of measurement for this variable would be interval, because 0 means that somebody thinks that abortion could always be justified, as opposed to not an attitude about abortion, right? Like, so this is one of those interval 0 to 10 scales. Age is also one of these, like you could measure age in a, technically it's ratio, like I guess you could be 0 years old, but I mean, the way that we would usually measure it is that 0 wouldn't be in our data set, but it would be something like 18 to whatever. And so here you can see on your screen a bivariate, what we call a bivariate scatter plot, where we're looking towards attitudes towards abortion. That's on the y-axis running up. We've got 0 to 10, and we've got age in 10-year increments, which is fine. We've got equal intervals between them, going between 10 and 90. And so here you've got this nice clear regression line. All of those red dots are people, participants, one of those 100 people in there. And so you can see the red dot matches, like you can see their age and where they are on the abortion attitude scale. And you can kind of see that it clusters. Like the younger folks are much more supportive. They're closer to like the 0, which means that you can always justify reproductive health care, all the way up to, the older people are, the much more likely they are to be opposed, to say, no, you could never justify this. So that's the bivariate scatter plot. If you wanted to put this into a table form instead of a figure form, or instead of a picture form, this is what it would look like. So you've got y equals 0.46 plus 0.1x plus e. So y is the attitude towards abortion, x is age, and e is the error term. And we can kind of get this. We get this from the actual table that you see on your screen now. So you've got the variable that we're interested in. Here we've got age, the intercept we know that we need for the equation. And you've got the coefficient, which tells you the effective age. And you've got on the dependent variable, and you've got your t-test and the p-value there. So the p-value is telling us that, imagine these data were real, that we could generalize to the population that they came from. And what we're getting here is that as age increases 1 unit, attitudes towards abortion also increase by 0.1. And so here we've got age measured in years. And so one way of interpreting this is that for each year older, or at least I guess that 10-year bucket, for each like unit that somebody gets older as we've got measured, they move up that 0 to 10 anti-abortion scale 0.1 of a point. And so if you magnify that by like every single year, then you can totally see how you get that effect that you see in that table. But that's how you would interpret that coefficient. For every like unit change in that x, it produces a, coefficient sized change in the dependent variable. So for every unit increase in age, you get that 0.1 increase in that 0 to 10 anti-abortion scale that we're using in this particular example. Now, the first thing that you're going to want to do is think about control variables, right? We're looking at age and attitudes towards abortion. So we know we can't have spuriousness because there's nothing that's going to make people younger. There's no kind of like force out there that's going to make people younger for sure. And so one of the control variables I want to propose is this idea of religiosity. And so it seems plausible that the more religious somebody is, the more likely they are to be anti-choice, the more like not religious someone is, to the point where they're just like, religion is not important to my life at all, they're probably going to be more likely to be pro-choice. And how this is basically getting at the idea of like how devoutness structures attitudes towards abortion. And if you're thinking about it, like what might, if we can control for religiosity, what might that do to the relationship between age and abortion? Would it make it bigger? Would it make it weaker? Would it stay the same? What I'm trying to dance around with is this idea that religiosity is probably a causal mechanism for the effect of age on attitudes towards abortion. So the older somebody is, the more likely they are to be religious. It's that religious socialization that's giving them a lot of information about how they see reproductive health care. Again, this is the whole like Irish example with the Constitution and all that stuff. And so as like the older somebody is, the more likely they are to be religious, and it's that religious socialization that makes them take particular views on abortion. The younger somebody is, they're not necessarily, the less religious that they are, which means they're not necessarily getting that same kind of religious socialization. What does this make religiosity? It makes it an intervening variable. And so you know from last week that intervening variables, if you actually have a causal mechanism, what you're doing is you're going to see that original relationship between the independent variable and the dependent variable weaken or disappear, right? Another way of looking at it is like the actual example that we've got on your screen here. Let's say that you've got, we're looking at a sample of 100 people broadly associated with Christianity in Canada. So let's say that people that go to church 4 times a month or more, we're going to say that they're the religious people. So this would be somebody who's attending at least weekly services, maybe more. They have an average or a mean score on the abortion scale of almost 7, 6.95. Their average age, their mean age is also 58. If you look at people who go to church less than once a month, we're going to say that they're not religious at all. They have an average score on the abortion scale of like 2.5. And their average age is also a lot younger. They're 26. So this is the idea that the relationship between age and attitudes towards abortion is accounted for because like younger folks are less religious, older folks are more religious, and that's doing the work on attitudes towards abortion. If you need to see it, this is what it looks like on your screen. So in the bivariate scatter plot, what you can see is that like we're imagining that we've got like 2 different chunks of people. The people at the bottom of the line, the younger folks who are more supportive of abortion rights, they're not religious, they're young and they're pro-choice, and then like you've got that other cluster of folks who are religious and older, and as a result, they're pro-life. So we get the computer to do the work for us instead of actually like trying to draw this out by hand. And here we're looking at the values of 3 separate coefficients. The intercept, what happens when age and religiosity are both 0. The effective age, and the effective religiosity. Now, if you remember from the very first one, the effective age was 0.1. So as age increased by 1 unit, somebody on that religiosity scale would increase by 0.1. You can see now in the table that that effect has been eroded. So the effective age is much smaller, and it's actually fallen out of statistical significance. You see the p-value there. P is 0.06, which means that we are just below that 95% threshold for us to be confident that we aren't making a type 1 error. So now at this point, we're like, oh, age isn't really having an effect. Whatever effect that might have been there from age, it's actually being driven by religiosity. So if I'm going to say that age is actually driving this, I'm making a type 1 error, possibly. Or like, unless I'm taking religiosity into account. So the reason why age might matter towards attitudes towards abortion is precisely because religiosity is doing this work. And if you look at the effect for religiosity, it's big. This is the idea that because this is measured in this hypothetical example for the number of times somebody goes to church in a month, increase that by 1, like church, like once a week, twice a week, once a month, twice a month, 4 or more times. Like this is readily and tangible. Like that increase by like one of those things, and you're increasing almost by a point, like 0.84 of a point in that 0 to 10 anti-abortion scale. So what you can do with that formula now is if you can make a prediction for any individual of a certain age and of religiosity. So if you know how old they are and how often they would attend religious services, you could actually like plug and play into this particular formula and figure out what their where they would sit on that 0 to 10 scale. Another way of looking at this is that a 0.84 coefficient for religiosity means that our regression predicts that as people go to church one more time a month, their attitude on the abortion scale goes up by 0.84 points if their age doesn't change. So if their age doesn't change, you can have like a 20-year-old and a 20-year-old, and one of them goes to church a bunch and one of them doesn't, you would see that difference of 0.84 between the two of them. So you can plug and play into the formula for any given individual. We usually don't do this because we're usually dealing with large samples. But the other interpretation that you could have if you're looking at this table is what's the effective age if religiosity is constant? So take religiosity out of it. What's the effective age? And the answer is not a whole lot. Like, there's not a lot independent effective age going on there. What's the effective religiosity if you hold age constant? And the effective religiosity is actually quite big. Okay. Here's another way of thinking about it. If you're looking at, if you're being kind of like, I don't know exactly how age and religiosity are working together in this particular example, the effective age is the slope of each line controlling for the effect of religiosity on attitudes towards abortion. So here you can see it on your screen, where what you're looking at is what happens to, like, so you can still see the effective age, but like where the level changes, it depends on like how religious somebody is. You can see like when folks are not religious, that's that green line, right? And then you've got the two red lines where like they're more religious, and then you get to like the one where you've got the most religious folks. That's X equals 4, X2 equals 4, religiosity in this case. Like, younger folks are still more likely to be pro-choice than older folks, but those younger folks, because you're taking religiosity into account, those younger folks are like way less supportive of, say, reproductive health care than are their folks or their counterparts who are a lot less religious. So you can see like the slope might be the same, but like where folks are coming in with like their levels are different. And that comes through pretty clearly in that figure there. Okay. So why do we do all of this? Like, the big summary I want to give is that multivariate regression for political scientists is really a useful extension of the more simple linear like models that have the two variables in it. And one of the reasons why we use it most often is that it allows us to reduce spuriousness in our models, because we're including like the real causes of our dependent variable in the model. We're thinking about them as causes because we've done that causal logic in advance, right? Like, the regression can't tell us what's causing things. We still have to do that causal logic work, but we can at least take multiple things into account at the same time, which reduces the potential for us identifying what's actually a spurious relationship. Another way of thinking about this is it's a way of testing whether or not a relationship is actually working through another variable, like getting at these intervening effects, right? This idea that the effective age on abortion is attitudes about abortion is really about how religious folks are, right? And you can see that there's age is doing work on religiosity, but like religiosity is really it's the real causal mechanism there.